Section 14.4 talks about adding and subtracting rational expressions with different denominators. These problems are going to be a little bit more complex than the ones we just did because our denominators are going to be different. So there's basically a 5-step process on how to solve these problems. So the first thing is we're going to look for the LCD of all fractions. Remember, the LCD just stands for the least common denominator. Okay, so least common denominator. We're going to write new fractions with the LCD. We're going to build up the numerators. That's the top part of the fraction. We're either going to add or subtract, depending on what problem we have. And then we're going to simplify. Okay, so our first problem here says add or subtract and then simplify. We're obviously adding because there's a plus in the middle. So the first thing we need to do is we need to find our common denominator. So what I'm going to do is I'm going to factor each denominator out. Well, 2x just means 2 times x. Okay. 3x really means 3 times x. So to find my least common denominator, I'm going to box each of those denominators once they're factored out. And I want you to notice I have 3 distinct factors. I have the number 2, I have the number 3, and I have the letter x. Okay. I need each one of those distinct factors. So I'm going to need the number 2, I'm going to need the number 3, and I only need to put down 1x. And the only reason I need to only put down 1x is because each of those denominators only has the letter x one time. So if we multiply that out, 2 times 3 times x, that's going to leave us with a 6x. Okay. So now the first step I'm going to do here, I'm going to rewrite the fractions with brand new denominators of 6x. Okay, it was a plus in the middle, so I'm going to put a plus in the middle. Now we already had the number 4, and we already had the number 9. We're going to come back and we're going to build up, because we've already rewritten with the new common denominators. Now we're going to do the building up part. So we're going to take a little look right here. We used to have a 2x, and now we have a 6x. So the question I'm going to ask myself is, what did I multiply 2 by in order to get 6? Well, I had to multiply it by 3. That means I need to multiply the top number also by 3. Okay? And I'm going to do the same thing over here. I'm going to look and see here I have a 3x, and now I have a 6x. So what did I multiply 3x by to get a 6x? We had to multiply it by 2. So I need to multiply that number also by 2. Okay? So 3 times 4 is going to leave me with a 12 for 6x. 9 times 2 is going to leave me with an 18 over 6x. I'm going to go ahead and keep my denominators the same, because now I have a common denominator. We'll add the numbers on top. So 12 plus 18 should give me 30. And then finally, the last thing we can do here, we can reduce 6 into 30. So 6 goes into 6 one time, so there's just my 1x. 6 goes into 30 5 times. So my answer is 5 over x. Okay. Let's see if we can do the next problem the same way, all right? Okay, so the first thing I notice is I have the letter b. Well, the letter b is just the letter b. I can't do anything with it. Second denominator is a number 5, and I can't factor the number 5. So my LCD, we're going to need each of these distinct factors. So I need 5 times b, which is simply just a 5b. Okay. So let's rewrite the fractions with our new denominator, 5b. Okay. And we're going to do a stare and compare. Notice what we used to have here. We used to have a b. Okay. Let me go ahead and write my, we had a 15a here, we had a 6b here. Okay. So let's come back. We had a b, now we have a 5b. So we're multiplying this one by 5. So I need to multiply that one by 5. Okay. Here I have a 5, here I have a 5b. So I'm multiplying this one by b, so I need to multiply that one by b. Okay. So now we'll go ahead and multiply straight across. 5 times 15a is a 75a, plus 6b times another b is a 6b squared, all over 5b. Okay. And now we're done. All right, so I hope this is sort of making sense. Let's take a look at the next one. Let's see if we can do it. Let's see. So here I have 3x plus 5 over 2x squared. Again, my first step is I'm going to take each denominator and break it down. Well, x is just x. 2x squared is a 2 times an x times another x. Okay. So I'm going to come back over here. I'm going to box my denominators. And I want you to notice something. So I essentially have two distinct factors. I have the number 2 and the letter x. But I want you to notice that this has more x's. So whichever one of those expressions in the boxes have more x's or more 3's or more 2's is how many times I need to write it down. So I'm going to use the number 2, but I'm going to use 2 x's. When we multiply that out, that just becomes 2x squared. Okay. So let's write our new fractions with 2x squareds. Okay. Now we already had a 3 here. We already had a 5 here. So now look at what I had before. I used to have an x. Now I have a 2x squared. So my question is, what did I multiply x by to get 2x squared? Well, I had to multiply it by 2x. Because 2x times another x would give me the 2x squared. So I'm also going to do it on the top. Okay. So now, same thing over here. I'm going to notice, look what I had before, 2x squared. And I still have a 2x squared. I didn't change the bottom, so I'm not going to do anything to the top. So now let's go ahead and multiply. 2x times 3 is going to leave us with a 6x plus 5 all over 2x squared. Great. Let's try this next one. Again, my first step, I'm going to factor my denominators when I can. So x plus 1, well, I really can't factor anything out of that. That's just x plus 1. However, 2x plus 2, we can factor a 2 out of that. That's going to leave me with an x plus 1. Okay. So now, my least common denominator, I'm going to box each of these expressions. And I want you to notice, I have the number 2, and they each have an x plus 1, and each one of those x plus 1s only occurs one time. Alright, so let's come back over here and write 2 and x plus 1 plus 2 and x plus 1. Now I already had the number 6 here, and I already had the number 10 there. So now we're going to do a little stare and compare. I'm going to look at my 2x plus 1 here, and here I just have an x plus 1. So I can see, well, I put a 2 on the bottom. That means I also need to multiply the top part by the number 2. Now I want you to carefully look at this expression right here and that expression right there. I want you to notice they're exactly the same, except one just happens to be factored out. So we didn't change anything here because it's really the same expression, so we're not going to change anything on top. So now let's go ahead and multiply those. So 2 times 6 is 12, plus 10, all over 2, and x plus 1. We'll go ahead and add the numbers on top. 12 and 10 is 22, all over 2, and x plus 1. And now we can finally go ahead and reduce. 2 goes into 22 11 times, all over x plus 1. And that is my final answer. Alright, so the next one we have here is 3 over x plus 2 minus 2x over x squared minus 4. Okay, so let's go ahead and factor the first one. Well, x plus 2, we can't really factor it. It's just going to be x plus 2. However, x squared minus 4, we can factor that using the difference of squares into x minus 2 and x plus 2. So again, if I stare and compare to each of these boxes, the two distinct factors that I see that I have are x minus 2 and x plus 2. Again, just a quick reminder, the main reason, or the reason why I only need to write x plus 2 only once, is because in each of these boxes, the x plus 2 only occurs one time. Okay. So now let's go ahead and come back over here, and we're going to write x minus 2 and x plus 2. This is a minus problem, so I'll put a minus there. X minus 2 and x plus 2. Now I already have the number 3 here, and I already had a 2x right there. So we're going to do a little stare and compare. I notice my common denominator is x minus 2 and x plus 2. Here I only have the x plus 2, which tells me what I'm missing is the x minus 2. Okay. Again, notice x squared minus 4. When we factor x squared minus 4, it's x minus 2 and x plus 2, and that's exactly what we have there, so we're not missing any pieces. So now, my first step is I'm going to go ahead and write my common denominator, x minus 2 and x plus 2, and let's distribute that 3 right up here. That's going to leave me with a 3x minus 6 minus 2x. So now I have an x minus 2 and an x plus 2. When we worry about now combining our like terms, 3x minus 2x, simply an x minus 6. And there we go. All right. So let's take a look at this next one here. The first thing I want to do, I want to think of everything as a fraction, so I'm going to think of that 2 as 2 over 1. So my first factor, x, is just x. 1 is just 1. So my LCD is 1 times x. Well, 1 times x is still x. Okay. So we're going to put an x here and an x here. We already had a 5 here. We already had a 2 here. If you notice, this x is the same as that one, so we didn't change the bottom. We're not going to change the top. Here I have a 1, but here I have an x, so I need to put an x up here as well. Okay. My common denominator is already an x. And now if I look at these two on the top, they're not actually like terms, so I can't combine them. I'm just going to leave it as 5 plus 2x all over x. Okay. Great. Let's take a look at the next one here. So again, my first step, x plus 4, well, that's still x plus 4. 3x plus 12, we can factor a 3 out of that. That'll leave me with an x plus 4. So come back here, I'm going to box this one, and I'm going to box this one, and I see that my LCD is 3 and x plus 4. So I'm going to write 3 and x plus 4, 3 and x plus 4. We already had an 8 right here, minus, we already had a 3 right here. Okay, now we're going to do our stare and compare. So let's take a look. Well, here we have an x plus 4, here we have a 3 and an x plus 4. So I know I need to bring in the number 3. Let's see, 3x plus 12, and we factor it out, is exactly the same thing there. We don't need to change anything. So we're going to go ahead and multiply these numbers. So 3 times 8 is 24, minus 3, all over 3, and x plus 4. So now we can combine those. 24 minus 3 is a 21, all over 3, and x plus 4. And finally, we can reduce. So let's see. 3 goes into 21 7 times, and x plus 4 is our denominator. I want you to notice that any canceling I'm going to do is always going to be at the very end. Okay, we're not going to cancel anywhere in the middle. The reducing is always done as the last step, and only when you can, okay? So let's go ahead and finish up section 14.4. We'll do this problem exactly the same way we did the other one. I'm going to think of that one as a 1. So y plus 5 is still y plus 5. 1 is just 1. So my LCD is 1 times y plus 5, which is still y plus 5. Okay. So we're going to write y plus 5 here, y plus 5 here. The first one didn't change, so that won't change. Here I used to have a 1, now I have a y plus 5, so I need to put another y plus 5 at the top. Okay. My denominator is y plus 5. And all we have to do now is combine our like terms. So 6y plus another y, 7y plus 5, all over y plus 5. Right. So let's take a look at this next problem. Okay, so we're going to have to do a little factoring here, but again, if you notice, since that number is a 1, we can go ahead and use our shortcut. So 1 times 9, I know is 9. What two numbers multiply to 9 and add up to 6? 3 and 3. So that's going to give me x plus 3 and x plus 3. There's my first factor. Second denominator is just an x plus 3. There's only one of them. But again, I want you to notice there's more x plus 3's here than there are there. So my least common denominator will be x plus 3 and another x plus 3, right? I have to use where my factor occurs the most. There's my LCD. So right here I'm going to write x plus 3 and x plus 3 plus, again, x plus 3 and x plus 3. We already had a 15 here. We had a 2 there. So this piece here is the same as that, just in its factored form. Over here, I notice I only have one x plus 3, so I need to bring in another one. Okay. So now I'll bring over my 15. What we need to do now, we need to distribute that 2. So that's at 2x plus 6 all over x plus 3 and x plus 3. Okay. And so now let's go ahead and worry about combining our like terms. So I still have a 2x, but we can combine the 15 and the 6 to leave us with a 21 plus. And x plus 3 and x plus 3, I'm going to go ahead and just write that as x plus 3 squared. I want you to notice I hadn't done that just yet because I wasn't sure if anything was going to factor. And to me, it's a little bit easier if I see my individual factors than, writing it with the square. All right. So let's take a look at this last problem here. So 2a plus 6, we can factor out a 2. We're left with an a plus 3. Well, a plus 3 on the second part is still a plus 3. So now I know that my LCD is going to be 2 and a plus 3. Okay. So let's write that out. 2 and a plus 3, 2 and a plus 3. So this factor didn't change, it's just factored out, so that stays at 3a. Here I have an a minus 1, but if you notice, here we don't, and here we have the number 2. So I'm going to put my 2 here, but I need to keep this in parentheses because I'm subtracting that whole thing just like we did earlier. So now I'm going to leave my 3a alone, and I'm going to think about distributing that negative 2. So negative 2 times a is negative 2a. Negative 2 times a negative 1 should give us a positive 2. Then here, this is 2 and a plus 3. Okay. So now, let's go ahead and worry about combining our like terms. So 3a minus 2a is just an a plus 2 all over 2, and then parentheses, a plus 3. All right, so that's 14.4.